लेते हैं।
आप स्टार्ट कर दीजिए तो जब तक के और स्टूडेंट्स आएंगे ना
चलिए
एक
ठीक।
मिनट बाद स्टार्ट कर दीजिए। लाइव होगा सेशन।
ठीक है, थोड़ा सा इंतज़ार कर लेते हैं। मैं तब तक थोड़ा ये टैब्स अरेंज कर लेता
सर जी सर आप स्टार्ट कर दीजिए।
हूँ। ओके, थैंक यू। ओके, thank you everyone for joining once again. We were discussing this problem yesterday, towards the end of our meeting, and we tried to apply different patterns for finding the longest common prefix. But the solution, Maha attempted on her and I attempted as well, and the approach turned out to be completely different. For me, it was more like, what does a prefix mean actually before we get into trying to utilize existing patterns? So a prefix would be something that starts with the zeroth index and could go towards all the way to the end of that string right here, okay? So for those who are new, let me give you a quick recap of what the question is saying, what the expectations are, and then we can jump into building a solution, a working solution for this problem, okay? So the question is, write a function to find the longest common string, prefix string amongst an array of strings. If there's no common prefix, return an empty string, okay? So a prefix will start with zeroth index, just like I said. So for this string, flower, for this string right here, if this is zeroth index, 1, 2, 3, 4, 5, you want to start calculating your prefix from zeroth index, and you can keep going all the way to the end, which means that a string itself could be a prefix itself, right? It can be used as a prefix. Okay, but you cannot say that this is a prefix because you're not including the zeroth index. That is the idea of prefix, not just a substring, because we're not required to find the longest substring. They're asking for the longest common prefix. Okay, and keeping in mind, don't get confused with this word longest. It doesn't mean you have to find the largest. It means it can be the shortest substring, such as F or FL, depending on whether it is common amongst all the strings whenever you look at a string and you're starting with zero. Okay, so that is the idea behind it. So what I'm going to do is I'm going to take a string, okay, and call it prefix, and then I can keep comparing that string as a prefix with all the other strings, okay. But what if the next string is actually smaller? Then flower, I cannot call it to be prefix of flow because it has two extra letters, E and R. So if I have allotted this flower to a variable prefix, now I have independence. I can change it, not change the string itself, but I can keep reassigning this prefix a new value, which means that I can keep taking the substring of this flower, keep reducing the substring window until I arrive at a substring that is common amongst all. Keeping in mind, they all start with 0, okay? So my new prefix in that case, when I'm checking the flow, would be FLOW, because now I have reduced my substring to this. The formula with that would be, I can do S dot substring, okay? S dot substring from where to where? From 0 to the length, okay? Length of this. So if I can get the length, it is total 4 elements. Okay. If I subtract, and here we have 6 elements, right? So if I subtract 6 minus 4, which means the difference is 2, I can just reduce two um, substrings, which are E and R, and get the flow. And what if I move forward? Now I have a new prefix that is flow. What if I compare this flow with flight? Now I have more elements. Well, now I need to look for the next window. In that case, O and W do not exist in this flight. So I keep reducing the O and W. Finally, I arrive at FL, which is common amongst all. And now that I've arrived at the last index of this array, I've explored all the elements, number one. Number two, I have a common prefix amongst all, and that is the longest one that we can have. So that is to say that what is the point in can we say that if we get the smallest substring, sorry, smallest string element, and we compare them with all, I can just take that as a common prefix. No, not necessarily, because let's say we have something like this, like dog, and I have flow, and the next element is flower, right? In that case, we don't have anything in common with the dog, even though we have FLOW and FLOW common here, but there's nothing in common, even though dog is the shortest string element, right? So this is not a workable solution. So in that case, we are always going to, or we can take the first prefix and just compare with all, and then we can keep reducing our prefix. And finally, if we're left with empty string, like there's nothing common, because we have to make sure it keeps getting reduced in order to find something that's common between them, then we can say that yes, we don't have any common prefix at all, or the longest common sequence as well, right? So in that case, return an empty string. What if this is null? This is not pointing anything. In that case, we need to return an empty string, because that's the requirement here. And what if this is the, um, let's say, just with an empty string? In that case, we don't actually have any prefix, right? So we're going to apply this formula. What if you have only one element? Well, in that case, since we are already reaching the length of the array with just one. So this will be your prefix. The first element will be your entire prefix, because in any case, we're taking the first one as the prefix element, okay? So this is the approach that we're going to take to solve this problem. Um, let's get into the coding part of it, coding aspect of it. So we have two questions we're going to solve today. One is grouping anagrams, which is a medium level question. We have discussed two different approaches yesterday. The most optimized approach is the one that I'm going to take for the grouping anagrams, and it's an interesting one actually. If any one of you hasn't used that approach before. Okay, so let's dive into coding. So the first thing I need to do is, for my ease, is initialize a um, string prefix, and set it equal to the first element. This is always going to be the first element of the input string. So I'm going to set it equal to the strs, which is my input, and the first index that is at the 0th index. Okay. But before I even initialize this first prefix, can I not include my edge cases? Edge cases would be that if it's null, if it's an empty string, I need to just return an empty string in that case. In that case, let me not even utilize any extra memory space, and just check for the first condition. If strs is equal to null, or if strs dot length, if the length is equal to 0, right? In that case, just return, if any of these condition is true, just return an empty string, right? Don't need to go further into initialize space. But if this condition is false, automatically you're going to come and you have to include this first, even if it's just one element. Okay. Next, what I do is I've initialized my prefix to this. I want to start iterating from the first element, right? So I'm not going to use for loops. I'm going to use while loops, and I'm going to use independent iterators. So I will initialize int I, which is usually something that we use for iterations, right? It's not mandatory, but it's easy to understand that way. For a lot of people, practice it like that. And I'll make sure that my I does not exceed the length of this array. So strs dot length, right? We'll make sure that it does not go out of bound. And next thing we're going to check is if strs of I, there's an inbuilt function that will take the substring, right? It will consider this as a substring, and it will consider it, and it will try to extract substring from this one, okay? If this is not matching the substring of this, then that means we need to reduce this, okay? So we'll use the existing internal Java method starts with, and what we're trying to check is the prefix, the first element. If it starts with the prefix, why starts with? Because we want to make sure it's starting with the 0th index. If it starts with the prefix, right, in that case, I can move my iterator forward to the next element, okay? Else, if it does not, in that case, I want to update my prefix in a way where it's reducing by 1. It's reducing by each element. So I'll update the value of my prefix. I'll update my value of my prefix to prefix, take the substring of the same prefix and set it equal to prefix, right? But by reducing it, string, substring, and of course, starting with 0 always. And next thing I'm going to do is I'm going to take the last element as the ending index. So whenever we use the substring method, the last index is not included. In fact, that is the limit, right? So this will not be included, which means I'm reducing the word flower. So if I'm saying, let me clarify on this concept a little bit. Where is my annotator? Right here. Okay. So if I'm saying that I want to take from 0 and length minus 1, this is your length minus 1, okay? This is the last index. So from 0 to length minus 1, this will not be included, okay? If I had another element, and I would do, I think, length minus 2, then this we could include this. Or we can just not put this limit at all and probably just include the entire array. In that case, well, we don't want to include this. So if we keep getting -1, it will keep reducing the last element until we meet a substring that actually matches this for prefix versus the new element, okay? So prefix dot length minus 1. And what do we need to check next? What if we have already reduced it to empty string, that there's nothing to match, right? Then in that case, we can just put a condition here directly. We don't need to even go any further. We can just put a return return command here. Prefix dot inbuilt Java function is empty. And if it is empty, we just return an empty string in that case, okay? All right, let's say if this condition is not being met and we have explored all the elements and we have met this condition already, we're exiting the while loop. In that case, whatever we have left with the prefix, we will just return that as the final answer, even if it's empty. But we're handling the empty string after the calculations here. So in that case, that's how we're going to solve this problem. So let me run this code and see if the first initial test cases are passing. If they are, then we can just go ahead and submit, and they should pass all the test cases. And it appears to be a good solution as compared to other submissions, but this could be a false positive for our efficiency. So this was the longest common prefix. If someone has any specific questions about this problem, we can address in the next 5 minutes. Otherwise, we'll move to the grouping anagrams.
So can I explain this problem, the code that you have written?
Yes, please. In the next 5 minutes, please. Thank you.
Can you show that?
Yep. Is this visible enough?
Yes. So what you have done, you have a first element of the strings. You consider that as a prefix, and then you will iterate through every string. And if that string start with the prefix, you keep iterating. Is it? Otherwise, what you are doing? What is the else statement? What is otherwise? What are you doing in the else part?
I'm reducing my prefix. So let's say my prefix is, initial prefix is flower. When I come to flow,
Okay.
What am I
Okay.
checking? First of all, if the second one was also flower.
I got it.
Okay.
So you have stated that it should be start from the 0, and it will you will write in that case you will update your prefix.
Correct.
And if the prefix is empty, you are gonna return that as an empty, because there are chances when, for example, the car and the dog, in that case there is no prefix. If the prefix is empty, we are going to return that. Otherwise, what we are going to do, I mean, we are going to return empty string. Otherwise, whatever the prefix will come, we will return that.
Correct. Okay, anything else?
It's clear now.
Okay.
So much
If
for
anyone else
explaining.
has any questions, please keep posting in the chat, and you guys can interact with each other in the chat as well. If you guys have the answer to a specific question, let's keep this interactive, at least at that end. For now, I'll move to the group anagrams because that was a more important question for us as part of our sheet. So let's follow here. Alrighty then. So quick recap of grouping anagrams. First of all, what are anagrams? Anagrams are something between two words, just a basic definition of anagrams. Between two words, if you can rearrange the letters of one word and it translates into another word, that second word will be the anagram of the first word. Or if you want to rearrange the words here and that results into the second one, this will be an anagram of this word. And therefore, if one word can be translated in another word by not replicating the letters, meaning all the letters, the number of times that they appear in one string or in one word, they appear in the other word with the exact same frequency. That's when you call two words to be anagrams of each other, right? Okay, so initially when we solved that, find out the valid anagram, it was pretty easy for us because what we used to do, we would initialize a dictionary in, for example, in Python, or a hash map inside a Java, right? Same things. What we would do is, let's say for eat, we would add all the letters. We would be given two strings S and T, right? For example, eat is S and T is T. And then once we had fed this eat with their count, how many times they're appearing, next time if we would encounter the same letters with the same frequency, we would subtract the count. And if we found out that any key value pair is now being evaluated to 0, which all of them are, we would consider that to be anagram because we were also keeping that map. We're not deleting the map, of course, but then we would check the size of the map. If the size of map is 0, which means there is no element left inside, in that case, we would say that these two words are anagrams. So it's pretty simple. But now when we're dealing with grouping the anagrams in a large set of data inside an array, where your strings can be jumbled up, where anagrams can be jumbled up, right? We were trying to take a window, but then we would hit something that's not an anagram, then we would skip it and iterate over another one. Then we have to come back and then we have to iterate, and the iterations can become pretty complex, and it reached a complexity of n square, and that wasn't a good solution. At least I didn't like it. But the next approach, another approach was that if I'm given an array, okay, and I want to find an anagram, what can I do so that I don't have to use two loops? Well, we have a method called sort, array.sort. And that array.sort, at least in Java, what it does is it can take a string, for example, this string, if you input in there, and it will rearrange them in an alphabetical order, which means that EAT will be AET, TEA will be AET. Now, if anytime we are encountering duplicates, just like this one, at two different indices, we can say that these two are anagrams because these can be rearranged into each other, right? So we used a common method, common standard for doing that. And the idea was that we can use a hash map and we can rearrange, for example, we rearrange this into AET. It did not exist in hash map already, so we put it as a new key and initialize a new array here. Anytime we encounter another string that when input into this sorting function, it resulted into the same key, right? These are same keys. We would add them to that list. Okay, but what about this one right here? Because this is a result of this first one. So that we have to make sure we're always adding that as the first element. Okay, so now, well, we're not storing AET, we have to store the actual elements, because once we're done with creating this hash map and we have iterated over all the elements, then we have keys mapped to, we have the lexigraphs ANT mapped to arrays with all the words that are the anagrams, right? So now we have groups, and finally what we do is we take a list and put all of these values of that map into another list. Okay, so and that's how we end up with this array, right? So what we're doing is we're iterating over all the elements one by one. We're rearranging each string to lexigraphs. The problem, however, here is the time complexity. It's not a problem. I think it's an acceptable solution. The problem, however, was the sorting itself. Sorting function itself takes O of n log n. On the top of that, we have O of n iterations going all the way to the end. So we have O of n log n taking more time than O of n. So we consider this complexity. So that was the worst time complexity for that array.
We will consider it big O of n square log n or n log n, because we are the approach that I have understood that we first we are going to run a loop on the whole string, and inside that loop, whenever we are going to extract an element, a string from the string's input, we are going to sort it. We will see if the key already exists or not. If the key already exists, we are going to put it in the value. But if it is not exist, we will make a new key, and same string will be assigned as a value. Same key, same value. So this is what I am getting. It means a loop inside a loop. The sorting. Is it going to be big O of n squared log n?
Or not a fixed size though. The strings themselves are not fixed size, where all the strings are of the same size. So we are not saying that we are running another loop on the exact same size of array. So can that be an O of, can that be O of n? No, I think it's going to be log n.
Can you drag a little bit and see what would be the size of the array?
Size of the string.
Size of it was yes, it is 100.
0
At
to
least
100.
length would be 100. So 100. Okay, and okay. Now it is justifiable that the length of the string would be 10 whole raised to power 4, but
This is
the
the array.
string length would be just 100. So we can consider it as a constant as well.
Yes. No, actually it can increase, right? So even if it is constant, it's not exactly constant. It can be
How?
1, it can be 100, right?
Yes.
So this is, okay, so let me clarify this. This is the length of the array. This is the number of elements you can have. So you can call it O of n. But this right here, it has a limit that's way smaller than, as compared to this one, it's way smaller than this. So the number of iterations you may have to do, it can be from 1 to 100. But here you're stuck with O of n. You have to make the 10,000 if you're given that. But here you can have less than that. So if you see that, my understanding is it's log of n. It slowly, it will increase, but insignificantly. Not exactly insignificant, but with like a very small measure as compared to, because we're comparing what is the part of code that can take the worst time when taken in the context of the entire algorithm, right? So I think that's going to be O of n log n. We can double check that. It's a good point, right? It's a very valid point. I'll just use GPT directly to pull it out. grouping anagrams time complexity for lexicograph method. What is it? So in that case, time complexity is actually O of n, O of, oops, what's that? O of n times k log k. Sorting each word is O of k log k per word. For n words, it's going to be O of n multiplied by k log k. So each string and then the size increasing for each string. So it's going to be O of k log k. Yeah, I think that would be a more appropriate way. K would be your string and how it can increase or decrease with the log k. That's your 1 to 100. And the k is the string itself. Let me know if someone else can add some clarity to this. But for now, that's the understanding I have. But that's not the solution I'm going to implement for now. So let's see the grouping anagrams. Okay, where was I? Okay, so we were saying that for sorting these, the complexity can be O of k log k with the correction that we have made, right? O of n multiplied by k log k. For all, you're checking each string, and the string can increase with logarithmically, so or decrease logarithmically. But yeah, anyways. So, but I can skip the sort part of it actually. And how we do that is instead of sorting these strings, what if we have a function? What if you have a function, we have a way where we can create signatures, right? Signatures based on frequency. And when I say frequency, you might be imagining hash maps, but that's not how we're trying to do it, right? Frequency meaning how many times a letter actually appears inside a string. We know that we have total 26 alphabets, 26 distinct alphabets, okay? But what if I had a way where I can find out what is the frequency and then I can match the frequency of one string with another string, but that frequency will be represented by some kind of signature. So if signature 1 is for the eat and signature 2 is for T, right? Is for T. If these two are matching, then I can say, yes, these two are anagrams for each other because the frequency of letters have to match, right? Because in the first valid anagrams problem, what we were thinking about is if an anagram is valid, first of all, the length of the string has to be the same. Second, the frequency of the letters that appear, that has to be the same. But if the frequency is the same, exact same, then we can say that yes, we have, and these are all the letters in there. Then we can say the lengths are same. If the frequency matches, and those are the only letters that there are, the letters are also matching, that we can say that yes, these two are anagrams. How we're going to do that? How we're going to do that? Somewhere Java has a feature where, let's say if I were to create an array A, B, C, D, E up to Z. Okay. And I say A lies on 0, and then 1, 2, 3, all the way to the 25th letter. The initial values for these are 0, 0, 0, 0, 0, 0. And mind you, I'm trying to create a signature, okay? Now, what I can do here is, if you see, E is separated from A by some difference of indices, right? This lies at 4. So what if I do A minus E? If I do A minus E, in that case, I have 0 minus 4. Now, of course, we're not going to consider minus, right? Because we're not going in the opposite direction, we're going the positive forward. So I can say that 4 is where E is lying. If 4 is where E is lying, then, and I found an E here, right? I can increment this to 1. So I found E once. Let's say if I'm given a string where I have E, 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 and T, I found another E, right? And E lies at index 4. I'll go back at that index and increment by 1. Eventually, by doing that, why? So you might think why I'm subtracting all from A. It's because A is a starting index. It's easy for me to navigate from A to E. I know it's only going to move forward. So if I do A minus E, string A minus E, then in that case, I'm finding the distance it has to cover to find where E is lying, or the index where E is. And I can keep incrementing that. And finally, I can have an array of integers where I have something like 1, 0, 0, 1, 0, something like this. It looks like binary, but we don't want to make it binary. So what we'll do is we'll iterate over this array and start adding it to a string. And so we can separate these by pounds or commas or whatever you like. And now we have a signature. We again arrive at T, we make it go through this formula, and we again come with the same signature. So if you remember, a few minutes ago, I told you we can use a hash map. We can put the, what can we put here? Is that if I sort these, I'll have AET, and then I will have an array. Now, instead of sorting something, what I will do is I will put signatures here. And I'll map the signatures to these arrays. Inside arrays, I'll keep storing these elements just like before. But you might be thinking like, why this is better? Because this direct subtraction of these strings, it gives me direct indices. I don't have to loop over them to rearrange the elements. I'm just keeping the elements where they are. T is the way it is. I'm not rearranging this. I'm just subtracting it from A to C in a 26 alphabet array. Where would E lie? And I'm just getting the index and I'm populating an array, another array with ones and zeros and 2, 3, whatever, and I'm mapping them, creating signatures, putting them in a hash map, and then finally return the array list of all the values. Okay, so that's what we're going to use now.
So I'm so sorry, sir. Can you explain it again?
Sure. Okay. Imagine A, B, C, D, E. How many alphabets do you have total? 26, right? English alphabets. Right? Okay. And what if I say that my A starts with, if I were to put all the 26 alphabets in an array of size 26, I have an array, integer array, and I'm putting a size 26. I'm putting all the elements in there, all the alphabets in there, starting with 0, 1, 2, 3, 4. Whenever you initialize an array, initially there are no values, right? I'll take this word, eat, okay? Eat, and I'll take A, just the string A. I'll pick E and do A minus E. This should give me 4 because A lies at 0, according to some Java backend library, whatever it is. I didn't understand that part. But this is how it's going to work. If you do A minus E, you get 4. Okay? Now, in that array, at 4, you have E. If you have E at 4, can I say I have found one E in that string and I can increment E plus 1? Did you get this part?
No. E plus 1 means?
Okay, E plus 1 would mean, let me redraw this. I should not skip that part out because I know it's going to be A, B, C, D, E. What I've done is I've initialized an array of size 26, okay? This is an array of size 26. I'm not assigning any values to A, B, C, D, E. This is just imaginary. This is imaginary. Initially, all the values in a new array, which does not have any values that you put yourself, all elements are going to be 0.
I got it.
Okay, yeah. And then these are also like indices, right? These are not just random. So if I want to find the 0 where E lies, I need to find the index. This is just imaginary, right? So if E lies at 4 index, I can increment it to 1. The same thing will apply for other elements. So that's how we keep repeating. Rest is clear. This was the only part that was confusing, right?
Okay, so
Mhm.
why we are doing this?
To avoid why we're doing this, in what sense?
We are storing the numerical values
Mhm.
by subtracting subtracting a, I guess so.
Yes, by subtracting from A.
Okay.
From A, we'll subtract. Okay, I'll take another example. TAN, for example, right? If I subtract.
Why we are storing these uh, in 26 array? Whenever the character is present, we are storing 1 over the same index.
Mhm.
I got this point.
Mhm.
When on that index, how we will get the index? By subtracting a from that letter, we will get that index, and on that index we are replacing 0 with the 1. I got it till now, but why we are doing this? How we are going to do something forward to it? Like how? Why we are making this array?
To create signatures. To create signature, we can see if I don't have this standard right here, if I'm just creating random signatures, I may not get the same signatures for the same words. Okay.
Okay.
This only makes sure that A is always going to be 0, B is always going to be 1, C is always going to be 2. Okay. This applies, if this is applying for 8, I can apply the same for T. Because if I want to evaluate where E lies for T, I can refer to the same index based system. I can
Okay.
just evaluate where E always lies, and I will always go to that and increment 1. Now, that means if the signature for this was, let's say, 001, E lied at 1. If I compute this and I want to compute E, again, E will always be at its own place and I can get 001. I can make sure by making it go through the same array structure, same indices, that E is always going to lie at 4. So if I'm finding E in T in 8, E will always give at the fourth index of that signature, E will always give me 1 at that fourth fixed position. And this
Is
will make
it
Mhm.
so? Are you doing it for the hash map
Yes, for
also?
the hash map. Yes, we'll use the
Be a
signatures.
key. It would be a key
Yes.
uh, that you are making, and against
Mhm.
that there would be values like eat, t, and 8.
No, against that, I will have the actual words. If my signature is
Yes.
matching, then
Yes, if
I.
the signature will match,
Mhm.
add you will add that in a value of that signature, right? Key value pairs, basically,
In
yes.
value, I have an array. If the
Yes.
signature of this match, I need to add this, of course.
Yes, it would be value, right?
Yeah,
This is
it
what
will
I'm
be.
saying.
Yes, correct. And then finally, I can return all the arrays. That solution.
So in this case, we are trying to override the sorting algorithm that we were doing.
Yes.
All right, now I got it. Thank you so much for
Yeah,
explaining.
no problem. So when you go into the bitwise operations and bitwise questions, if you hit a medium question, um, you'll be most likely forced to create bit mask that uses the same idea, like create signature or bit mask, create a string of bits that if you take its and with another string or with another bit string, that bit string gets manipulated according to this. ये बिल्कुल ऐसा ना जैसे आइसक्रीम आपने बनानी होती है और आइसक्रीम का एक सांचा होता है, उसके अंदर आपने जो है तो वो जामी शीरी डाल दिया, अब उस सांचे में उसने डाल के आइसक्रीम ही बन जानी है, राइट? ये बिल्कुल वही चीज़, तो आपने सांचे बनाने एक तरीके से. आई होप दिस एक्चुअली हेल्प यू गाइस अंडरस्टैंड एट लीस्ट दिस ट्रिक बेटर.
Now I got it.
Cool.
So you were saying, I just recall that you were saying that you don't know why it is happening. Basically, these are the ASCII values. The ASCII value of A, I think it starts from 65 and it goes on like 66, 67. And if we subtract that, we are going to, for example, if I subtract A minus A, this is going to return me 0. Why? Because 65 minus 65 would be 0. If I subtract B, it is going to B minus A, it is going to give me 1. Why? Because 66 minus 65, this is going to be 1. These are the ASCII characters.
These are the ASCII. Gotcha. Okay, so we are basically translating back into what, machine language? We're doing computation at that level. Am I assuming, or I'm just jumping to conclusion? S2 character array. Because we're not left with much time, I want you guys to have at least last 5 minutes to yourself so you guys can say or ask questions. So I'm going to explain this line by line once I have implemented this. Okay. String builder, key builder equals new string builder. And then we need to iterate to create the signature in form of a string. And where we'll take the signature from is this count, where we're storing the indices count, the one that we are just discussing a few seconds ago. And I is less than 26. We want to make sure that our signature does not exceed, or at least it has a limit for the sake of ending the loop. Key builder dot append. We want some sort of a separator, and just a delimiter. Okay, and then we can use the same. We can use the same key. Oops, what is that? No, not the entire solution. Key builder dot append. And we can store count. Okay. What are we getting from that array where we're creating the signature based upon these subtractions for the ASCII values? And finally, we can store it inside a key, and we can convert it to string. We can convert it to, this is right now just an object, and we want to just convert it to a final string. And now we need to initialize our map. I'll give you a quick recap of how if this method works, the compute if absent. It's a lambda function inside. I'll explain it once we're done. Move array list, array list, and add. We'll add the actual element by the name of s because that's where we're iterating, right? So we're just directly adding it here. We don't want any modified strings. And finally, I can return the new array list. Okay, that will have all the values of the map dot values. Okay. Quick recap of how it works. Okay, first of all, we initialize a map, an original map. where we'll be storing the lists of strings, and here we'll be storing the signature. Okay, we initialize a new object of the hash map. We iterate since we want to. It's a string array. We're just iterating over it with the string, and we loop over it. We initialize a new array with the count 26 for all the alphabets, right? And for that array, what we're going to do is we're going to subtract that. This just means take this, convert it to a character array that looks like E, A, T, okay? And then iterate over that character by character, and then take that character C, subtract it from A. So I think they're trying to avoid the negative values. You get, let's say, E minus A, it will be equal to 4. And 4, if you put count of 4 plus plus, that is equal to going at the fourth index of that count array that you have created with this, okay, and incrementing it by 1. So if at E you had 0, now you have done it plus 1, and then you can continue doing that. Okay, and then here you have string builder. It's an inbuilt Java class. You're initializing, it has like more advanced features, so that's why we try to use this often. For integer I equal to 0, I is less than 26, you're going to iterate over the, okay, this right here. Once you have that count with 1, 0, 1, 0, 1, 1, for example, you want to create a string where these are separated. It creates a proper signature, right? And in that way, you're going to append the hash after every character while iterating over the, so you're iterating over this entire array, which is 26 length of this count that you created right here is 26 because we initialized it by 26. You're going from 0 to all the way to the end, okay? And appending after each element, you're appending this and adding it to a string. Once we have added to the key builder object, you just convert it to string. And this method right here, it adds it to the map. So if what this method does is, if the key does not exist, if the key is absent, if this signature is absent, add the signature and create a new list. Inside the list, add that S element, which is this right here. If it already exists, then in that case, this function is returned. It returns a list that already has that element, for example, 8, and adds the new S that has been found. That will only happen if your S has arrived here, okay? And then adds a new one, which will be T. And similarly, continue doing that. And finally, to return a new list with map.values. Whatever you have in the arrays of that map, it will get returned, right? So let me quickly run this code.
Sir, why are you appending hash? Hash key, why are you?
I think we can do it without that as well, but this is not going to affect anyways. You have this string being computed to a certain value. If those strings are matching, then I think this would not make any difference. But I just did that for my so I was going to use comma or anything like that. But I don't think there has to be any reason behind it. So I think we can just without that as well. I accept it and let me speed it up. Wrong answer. 125 cases. But if you submit with this, it should have worked. There's something that is actually, I solved this while discussing it with GPT. The way I use GPT is I tell it not to give me any solution or hints. I give it a proposal and it challenges my, so in there I mentioned, can I use commas? And then it suggested this. So I think that's the reason. but there has to be some reason behind it. We have not left much time to explore this further. Actually, we can look into it. This is a good question. Why we use this? Let's take a look at this. Why are we using this? The reason appending before count I is your code create a unique and unambiguous key. When building the string that represents the character counts, counting characters to group anagrams. If you're using character frequency count to create case, you build a string that represents how many times letter appears. That I'm understood. Suppose you count like these. One means appears once, B appears 11 times. If you just concatenate counts without anything, both generate well. Okay. So I think for this case, if a letter is appearing 11 times and it's appearing 1 and 11 times, in that case, it'll cause confusion. We need some kind of separator between them. So I think that's what happened when we looked at the failed condition. Feel free to look into this further. I'll pose a solution. Here we have like B, D, 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 and then we have all the B's. So somewhere around there, if you don't put delimiter, 2 and 22 and 22 and 2. So you cannot create unique maps for 2 and 22 and 22 and 2. If you're appearing like this, you'll just get it like this. And then you'll be matching it with the wrong anagram. Okay. So, but if you're doing it like this, and you're putting a delimiter between them, you can distinguish which ones are which. So that's how it will create unique key. Otherwise, you'll have just numbers, right? You'll have just counts. So we need to have some kind of, for any kind of signature, we need to have some kind of delimiter. So I think that's the reason why we're doing this. Okay, over to you guys. Thank you all for your patience and supporting me throughout this difficult journey.
Thank you so much, sir. You are explaining very patiently and very calmly, और आपने बहुत अच्छे से explain करते हैं चीज़ों को बड़ी clarity के साथ. I really appreciate that.
Thank you very much. जी, क्वेश्चन है
जी ग्रुप के नाम से कोई किसी क्वेश्चन है, काइंडली अपना नेम चेंज करना, अपना क्वेश्चन करना.
अस्सलाम वालेकुम सर.
वालेकुम अस्सलाम.
सर तलहा ने ना उधर स्लैक पे किसी बच्चे ने क्वेश्चन पूछा था कि भाई हम अभी बिगनर है तो हम क्वेश्चंस को कैसे सॉल्व करें. तो सर तलहा ने एक लिंक शेयर किया था बिगनर्स के लिए कि पहले इनको सॉल्व करें और फिर लीड पे मूव करें. तो फिर हमारी स्ट्रेटजी क्या होनी चाहिए उन क्वेश्चंस को सॉल्व करने के लिए, क्योंकि वो 900+ क्वेश्चंस हैं. तो क्या हम सबको सॉल्व करेंगे?
नो 900 प्लस है.
वो
अच्छा,
आइलर करके था कुछ, ऐसे करके था कुछ.
सिंपल प्रोग्रामिंग प्रॉब्लम्स मैंने दिए थे आई थिंक उनको. उसमें एलिमेंट्री और लिस्ट और स्ट्रिंग्स अगर आप कर लें ना पहले वाले इंटरमीडिएट को छोड़ के भी, तो आपकी एनफ फाउंडेशन आ जाएगी टू गेट स्टार्टेड विद लाइक लीड कोड स्टाइल क्वेश्चंस. मैं लिंक शेयर कर देता हूँ अगर, ये मैंने मैसेज में
सर
किया. जी जी
एक बार आप दोबारा लिंक शेयर कर सकते हैं उसका,
जी जी,
या
आप
फिर
मुझे
आप.
पिन कर लें स्लैक पे एक मरतबा. ठीक है, ये अभी मीटिंग बंद हो जाएगी खुद ब खुद तो.
जी ठीक है.
और मैंने लिंक शेयर कर दिया था मीटिंग चैट में. आप लोग सिंपल प्रोग्रामिंग प्रॉब्लम के नाम से गूगल पे. ठीक है, जज़ाकल्लाह खैरन कसीरा. बहुत बहुत शुक्रिया.
ओके,
इंशाल्लाह
थैंक यू
कल
सो मच
मिलते हैं.
फॉर ओके, थैंक यू सो मच फॉर पार्टिसिपेट्स एंड मॉडरेटर. थैंक यू सो मच फॉर मोहम्मद तरा, आपने बहुत अच्छा एक्सप्लेनेशन किया. और हम किसी का क्वेश्चन है तो काइंडली पूछ लें, अदरवाइज तो हम सेक्शन को एंड करते हैं. हमारा सेक्शन का एंड हो चुका है.
Thank you, जी. Allah Hafiz.
थैंक यू. अल्लाह हाफिज़.
अल्लाह हाफिज़. अल्लाह हाफिज़.
अल्लाह हाफिज़.